Hey guys, welcome to 2.4 Chain Rule Day 2. In this video, we're going to be extending the chain rule, but we're also going to be applying the derivatives into things that we've already been doing, such as finding horizontal tangents. Okay, so we're not learning anything new. We're just going to go ahead and just extend our chain rule lessons along with applications of derivatives. Example letter A. Find the derivative and do not leave negative exponents or complex fractions in your answers. So I need to convert this into a power. Cube root is the same thing as 1/3. Now take the derivative. So f prime, we have a power. Drop the 1/3 to the front. 1/3 4x cubed squared plus 7x. Take 1 away from 1/3 and you get negative 2/3. But you're not done. This is the part that everybody always messes up, is that they forget the chain rule. They did the power rule correctly, but the chain rule they messed up, so it's times 8x plus 7, and that is my answer. Now I can clean this up and say that it's going to be 8x plus 7 over 3 cube root of 4x squared plus 7x squared. The square on top means it's being squared, and the cube on the bottom means it's being cube rooted. Next one. So this is one that this is a tough one right here. So let's rewrite this as sine x cubed to the fourth. Now let's apply the power rule and the chain rule. So drop the 4. So y prime or dy dx is equal to 4 sine, take 1 away from 4 and that's going to be 3, keep the angle x cubed, and then take the derivative of the inside, which is going to be cosine x cubed, and then finally take the derivative of the angle, multiply it to the outside, which is 3x squared. That one had a double chain rule. Got to be very careful. So let's go ahead and combine these. 4 and 3 make a 12x squared, sine cube x cube, cosine x cube, and done. Another very similar problem like letter B, we have tangent of 5x cubed. Y prime is 3 tangent 5x. Take 1 away from 3 and that becomes squared. Take the derivative of tangent and that is secant squared. Keep the angle. Now take the derivative of the angle. There it is. There's my chain rule. So this became this and that became that. It's like a chain, right? So it's 15 tangent squared 5x secant squared 5x. Next problem. Ouch. Quotient rule. Okay, so this is my u, that's my v. Let's go ahead and just write it up here. U is 5x. That means u prime is 5. V is 1/3 x squared plus 1. Oh no, messed up. Wrote it the other way around. It's x squared plus 1 to the 1/3. So that means v prime is 1/3 x squared plus 1 to the negative 2/3, and then chain rule 2x. This is going to be so painful. Okay, so let's go ahead and do our quotient rule. Okay, because they're being divided, so it's going to be f prime of x is equal to bottom, which is x squared plus 1 to the 1/3 times the derivative of the top minus the top times the derivative of the bottom, which is 2x over 3x squared plus 1 to the 2/3 all over the bottom squared, which is x squared plus 1 to the 2/3 as well. Because if this is the original, then squaring this means I just put a 2 right there. And there's my derivative, okay? Now I know in another video we did the exact same function, the exact same derivative, but I want to go ahead and just continue with this. So when you're dividing fractions by another denominator, all it means is to multiply and multiply the denominators by the main denominator. So it's going to be x squared plus 1. Well, let's bring the 5 to the front, right? The 5, let's bring it to the front. 1/3 over x squared plus 1 to the 2/3 minus, now this becomes 10x squared over 3. Multiplying these two together, notice I have a square and a square, so that means all I have to do is just add them. So it's x squared plus 1 to the 4/3, and I really don't want to go any more further than that. And there's your problem. There's your answer. Okay, one more problem before I break the video into the next page. Now we're going to do an application of derivatives. Write the equation of the tangent line to the graph of y is equal to 2x cubed plus 5 squared at the point -1, 9. So tangent lines, okay? What do we need for a tangent line? Well, we need a slope and we need a point. Now we're given the point, -1, 9. Now we need the slope because we want to put it in y minus y1 m x minus x1. So let's go ahead and do the derivative. That's how we need to get the slope, by taking the derivative. So y prime is 5, no, not 5. It's 2. Bring the 2 down. 2x cubed plus 5 to the first, which we don't need to leave. And then the root of the inside, this is a simple chain rule, right? So it's going to be 6x squared by itself. Now, whenever you have to plug in a point into your derivative, okay, notice I'm only plugging in -1 because I only have x's. I don't have any y, so there's no need for me to plug in 9 into my derivative. Later on we will be plugging in x's and y's, but since I only have x's, I'm only going to plug in the -1. Now you don't need to clean this up. If you're going to plug in a number for every x, there's no need for you to clean it up. So it's going to be 2 times -1 to the 3rd plus 5. And this is where your PEMDAS really kicks in, because now you're going to have to multiply, square, you have to follow order of operations. So let's continue. What is -1 squared? Well, that's -1 times 2, -2 plus 5. What is -1 squared? Well, that is +1 times 6. So I really have 2, 3, 6, which is 6 times 6, and that is 8, no, not 18, 36. That is my m. So that means that I have my y minus my 9 is equal to 36x minus a -1. There it is. Don't simplify any more than that.